Today, I'm going to discuss with you parallelogram law of forces. And here, parallelogram law of forces is usually used to find the magnitude of the resultant vector. So, parallelogram laws of forces applies for two forces acting simultaneously on a body. This is a body, and for us to apply the parallelogram law of forces, this body must be acted. So this body must be acted upon by two adjacent forces, F1 and F2. In this case, there is an angle here, and in this case again, here the parallelogram law of forces qualifies to be our best alternative to handle such problems. So usually, the resultant vector of two adjacent forces is calculated using parallelogram method, and it is usually the larger diagonal of the parallelogram. Look on this diagram, I'm going to show you. So, this is the diagram. I'm not accurate because I'm free sketching for you to understand. Then, let's say this force and this force, this one is named F1 and this one is F2. And they are concurrent, meaning they are from a point, and the angle between F1 and F2 is 70 degrees. So it looks like a parallelogram. In this case, we will now transfer this length to the opposite side here, this way. Again, this length for F1, we transfer it to the opposite side here. Here there is no arrow. Our arrow is here. This is F1. You can see this length to this length, this point to this point. Then our resultant vector is the bigger diagonal. This is the main diagonal, forms our resultant vector. After understanding that, we know that the 2 points or the 2 angles, this angle and this angle in a parallelogram, the 2 angles adds up to 180 degrees. Let's say this is theta 1 and this point is theta 2. So theta 1 plus theta 2 are supplementary angles. Meaning they add up to 180 degrees. in a parallelogram. So you can see this forms a triangle. So we say we will draw this separate. So it looks like this. Then when here was 70, let's say the angle between this and this was between F1 and F2 was 70. But after transfer to the other side, F1 becomes this side. And F2 remains here. So this one is the resultant vector. So we can say this resultant vector or the resultant force is Fr. And after knowing that this point was 70 degrees, then we'll say, since it's a complementary angle, supplementary I mean, therefore it is 180 minus 70 will give you this angle theta 2. That is 110 degrees. So this is 110 degrees. After knowing that, we can calculate the magnitude of the resultant vector or the resultant force Fr, having given the magnitudes of F2 and F1 by using the cosine rule. Then let's say F1 is equals to 90 newtons and F2 is equals to 75 newtons. Then we will say this part is equals to A, this side. Let me draw it here so that you can see it clearly. So this is 110 degrees. This is Fr. Let's call this side of Fr is equals to C. And let's say this side where it is F1 which is equals to 90 Newton is equals to A. And then this opposite side for F2 which is equal to 75 Newtons, this one equals to B. So you know, having cosine rule and given one of the angles and the value of two adjacent sides, we will say C squared is equals to A squared plus B squared minus 2AB cos C. Then from there, we will say this is our capital C, because it is opposite to this, to the point C. Remember, it looks like mathematics. It is a mathematical formula, of course, but we apply it in such cases. Then this one, which is F1, which is A, the opposite side, the opposite angle is this point. So this is capital A. Then our B is here. The opposite side is here, capital B. So this angle, and this angle. But our main interest is at this point. So we will say to find the resultant vector FR, which is C small caps, we will say C squared, which we don't know, equals to A squared, and A squared is 90 squared, plus B squared, which was 75, so B squared is 75 squared, minus 2 into A, which is 90 times 75, which is the value of B, cos C, and the angle C is 110 degrees. You can see 110 degrees. Then you take your calculator and evaluate. 90 squared is 8100 plus 75 squared, which is 5625, minus 2 into the bracket, which is 90 times 75 cos 110. This gives you negative 2308.64. Then it is 8100 plus 5625, minus times a minus will be positive, plus the value of this times this, which is 4617.28. Therefore C squared equals to this. C squared equals to the addition of all these, and the addition of all these gives us 18342.28. Then C equals to the square root of 18342.28, which is equals to 135.4 newtons, because you can see FR was equals to C. So we represented FR by C. So FR is equals to 135.4 newtons. This is it. So that is how we use parallelogram law of forces to calculate the resultant vector and the magnitude of the forces